Please, ladies and gentlemen, welcome our President who's come from Tel Aviv to support our event, Amnon Bar-Lev.
Good morning, everybody. Thank you for coming. You have to admit that my boat is much more fun than Kurt one. There's no food on the boat, though. So I'm going to talk a bit more about security from a bit high level. I'm not going to talk about specific product. What I want to present to you is an architecture. It's a concept of how you look at security. And I'll go through a bit of a background about what happened in the security space, and then basically try to give you some kind of an advice or a blueprint of a way that when you build your own environment, what you're doing today, to give you maybe another look of what you do. So let me start. This is trivial, right? We all know that technology is everywhere. Our kids probably know that much better than us. They actually were born into that. I think that you go kids, they look at stuff and they want to enlarge them, right? This is the way they do stuff. That's really not new, and I don't want to talk and state the obvious, but I think there are a couple of things that are new in technology. Technology became much more open and much more connected on everything. When I say everything, I really mean everything. And I'll give you a couple of examples. I think the easiest one is ATM machine, right? You think about ATM machine. About 5 to 10 years ago, it was proprietary IBM system. Very closed. Nobody could do anything into that. It was quite difficult to hack into that. Today, it's Windows. Some of it is Windows XP unsupported, okay, with vulnerability inside, and it still is there. The reason why it's becoming IP open is because you can now push application. You can do a lot of good stuff from the application perspective, but openness usually brings vulnerabilities, and today people can hack into ATM machine. You're going to have a lecture about other stuff. You go to the cinema, right? You run your credit card to get the tickets. Do you know the system can be hacked? They can get all your stuff very easily. You're walking on an airport. You see those gates that nobody's there. There's a port. You can go with your computer, plug in. Surprisingly, you can get access to systems. So that's like one level of our daily life. But then think about really what's driving our life. Think about electricity, water, transportations. All of those environments running IP networks today. On top of it, there's a protocol called SCADA. So all this critical infrastructure today is really vulnerable. We don't understand it. It's far away from us. But think about Australia, right? You're really far away from everybody. If people want to get into here to do the hard stuff, it's very difficult for them. It's really, I know I flew over here. It's like 11 hours. It's really far. You need to do something about it. In cyber, there's no distance. They can do the same thing over here or everywhere they want. That's a big change. So technology is no doubt ruling our lives. Amazingly how much. We don't necessarily know about it like every day, but it's there all the time. And if something doesn't work, we're really fully dependent on it. Now it's become very open, very connected, and it's come with vulnerabilities. The second trend that we've seen is what happened to hacking industry. And hacking industry evolved dramatically. The first thing, as I said before, it's an industry. It's really an industry. And I can show you a screenshot of application that you can go to the internet and just buy hacking tools. It's quite straightforward. If I want to attack an IP address, I can go, there's a SAS model, I can go into that, decide which the IP address is, where do I want to attack it, and which protocol, UDP, TCP, run a click, and you're just out there and attacking somebody. It's become an industry because they get to the level where there is a separation between the people who create tools and using the tools. I'll give you an example. When you want to hunt, many years ago, would you like to hunt? You'd go out there, build your own weapon, running after the elephant and catch the elephant, right? Today, if you want to hunt, all what you do, you first go to the store, you buy a gun. So somebody else produce the tool for you that you can go out there and hunt. You don't need to have the skill set of building a weapon. You just need the skill set to use it. And that's what happened today in the cyberspace. You don't need to be an expert. You just need to have enough money and an evil meaning. That's all. So if you have these intentions and enough money, you can generate any attack quite fast. You don't need to be a geek or anything. It's became really, really a commodity. So when there is a power and when there is a means, people using that. The second thing that happened is motivation has changed. So motivation used to be, many, many years ago, it used purely ego. There was, I don't know if you know, there was hackers and crackers. There was a big difference. Hacker, actually the good one, that was just penetrate into your system and said, hey, there's a vulnerability over here, and they'll go away. The cracker will do some bad stuff for you. Then motivation became financials, because there's more and more financial things that you can do, and we see more and more of that happening all the time. Then it's moved out to be political motivations. You see countries. Countries sponsors things that happen. Most of the Western armies around the world, or most of the modern armies around the world, have cyber warrior. It's not only that they protect, they actually attack. Because if there is a power, and if I want to start any conflict, and I will start it with a cyber attack, think about it. Again, no electricity, no water, and you start a confrontation in a much better situation than anything else you can think about it. The best example will be Stuxnet, an attack that happened like 4 years ago on a nuclear plant in Iran. Massive damage, and nobody knows who did it. Some people blame my country, some people blame others, but really nobody knows. No war was declared. Nobody was injured, nobody died, no bombs. Still a big damage happened with a small USB device that was plugging into Siemens equipment. So it's quite amazing to understand that. So we clearly see a big things going on, a shift on the cyber. That will not change as long as there's power and vulnerability in technologies. And apparently there will always be vulnerabilities in technology. We can solve these problems. A couple of examples to show how it's became a commodity. So this is a price list published by Forbes. As you can see here, iOS is still the most expensive one. If you find a 0 day, you can sell it. Instead of going back to the manufacturer and say, hey, do you have a problem, fix it, people start selling it. So this is a price list you can actually get money. It's actually give more people to focus there and to try to find more vulnerability and sell it somewhere else. This is another example. This is a piece of software, download to your computers because you get an email or a website, and it's encrypt all your data and telling you this is how much you need to pay. So it's very interesting. If you're in the US, you're going to pay $300. If you're in Europe, 300 euro. So you need to be in the US. It's better from currency perspective. If you didn't pay them for 2 weeks, they will take your keys and throw it away. You'll never see your data again, period. By the way, the same attack is happening now on Android devices. So there's really no shame anymore. Blackmail and all of that, it's really, really happening all the time. So we've seen network open. We've seen hacking all over the place and more like that. And the last thing is what happened to our networks. This is not that long ago, at least compared to my age. I would say like 10 years ago, 15 years ago maximum. All what we used to have is a few servers, a few screens. We were advanced, we would connect it to the internet, and that was very straightforward. But now business started to evolve. We clearly see that's happening, right? So people said, hey, I have those branch offices. I need to have one in Sydney and one in Paris and one in London. I have now those clouds, right? So I will connect more clouds to my IT environment. I have those now mobile users traveling around. And actually, I find myself with that kind of environment, which is great, because it's meaning your business continue to grow. The needs continue to grow, and you actually serve them. It just became much, much more complex. And when it became much more complex, people understand the need for security and think about your environment. They said, OK, I'm going to use technology in order to protect technology. So that's what I'm going to do. And that's the way my network is going to look like. And think about your network and try to draw it. You see something like that. You have a significant amount of security technologies. You have a firewall and a VPN and URL filtering and application control and threat preventions and all of those huge amount of technologies. No doubt, it's very, very complicated. And Check Point have about 100,000 customers around the world, and a lot of them here in Australia. And I'm meeting a lot of them. And when you go out there and have some discussion with them, they say, I really don't know how to manage it. It's become very complex. And I have basically two problems. My problems, the first one is, this is my environment, and how do I do my daily life with it? And the second question, which is probably even more important than that, they ask, am I doing the right thing? Look, security is the only place in IT where you fight somebody else. Think about networking, storage, application. This is all, am I doing a better technology? Did I push the limits of physics? I have other ideas. Here, there's just somebody else on the other side. So the progress in security is much faster than anywhere else. The resources that the other side investing continue to grow because the gains continue to grow. So most of the people are not focusing only on security. They're focusing on the business. They find themselves in a situation that they're not sure that they are up to date. You know, they open the papers and they see, here, this Office Depot today. Yesterday it was Target. The day before it was RSA or whatever it is. And they ask themselves, can it happen to me? And they don't have enough skill set or expertise to know what it is. And that way we go out there. We spend about a year and a half working with a significant amount of customers around the world to better understand what will be the blueprint, what will be the principles upon you build your security infrastructure. And there's a couple of characteristics for security. The major three principles are as such. One, modularity. Why is it so important to be modular? Because the problem is very complex, and the network is very complex. I can tell you about myself, I'm not that smart to solve a very, very complex problems. So the only way for me to solve a very complex problem is actually to break it to small problems. And that's something we all can deal with. Second thing is, because our network became so complex, we want to get to a template. You can say that I have those 5 branches, and I have 200 branches, but I have 3 types of them. And then I know how to deal with type A, B, and C. If you start creating a variant for everything, you're going to get into a mess. So modularity is key. And we're going to show you a couple of things about that modularity. The second thing is you have to be agile, because it's changing all the time. You want to have an infrastructure that tomorrow morning there's new technology for threats or technology to protect against threat. You want to use it in the same environment. It has to be really live and viable. And the most important things, it have to be secure. And you know, there's always this debate with customers about performance and other stuff, and I think it's crucial that security will meet the performance criteria and so forth. But remember, when you buy a security solution, make sure it's secure. Because if only what you care about is performance, my advice to you, don't put anything in the network. It's cheaper and faster. So don't go this route. That's important. So once we took all this principle, we come back with an architecture we call software-defined protection. Sounds very similar to software-defined network. And the reason, because it's the same structure of 3-layer architecture. The lower level architecture is the enforcement. I'm going to talk more about each and every layer. Enforcement meaning traffic goes through that enforcement point, and those enforcement points know how to block the traffic. The second layer is the control, where you create the protections, and then you manage it all together. So let me dive into each and every one of them. I'll start with the enforcement point. Different enforcement point here. Enforcement can be everywhere. Of course, you have those physical appliances that you plug into the network. You have virtual firewall, virtual gateway that you can provision from those devices. It can run on mobile devices, and we're going to talk more about mobility. It can run on desktop, laptops. It can also run in the cloud, and we are about to launch very shortly the Checkpoint Threat Cloud mobile, where we basically, what Checkpoint did, we built our cloud. So we took our gateways, we put them all over the cloud. We allow our customers, our enterprise customer, to push their policy to our cloud. So if I'm a mobile user, going away from the organization, and I still want to be protected, I have a small client on my device, it will route my traffic to that gateway. You push your policy to that gateway, go back the logs and everything, and you actually, mobile user will be protected the same way when they're outside and inside the organization. So that's just an example of cloud stuff. So we put enforcement all over the place. We have significant amount of them. And the question is basically, where do I put them? Again, 15 years ago, it was a very simple question, right? Where do I put them? I have a parameter. I have where do I connect to the network, no problem. I'll put here something, and I'm done. But where I'm putting that device here? So where is the parameter? Any idea? Cloud, is it part of your network or not? Mobile users, branch offices. We don't clear anymore. The boundaries are extremely not clear anymore. Of course, people can put a modem and connect to the internet from different places. More than that, you don't need to put a modem today, right? You take your smartphone, you make it a hotspot, you connect your laptops, and that's it. So from everywhere, all the time, for every network, you're really connected outside. We think that parameter is not the right approach anymore. It's great when you have it and it's well defined. In many cases, it's not. And the approach that you're supposed to take is a segmentation approach. Let's segment your network. Think about ships, right? Kurt mentioned before ships. Ships have compartments. Well, not in my boat, it's too small, but in regular boats, you see there are compartments inside. And if something hit the boat does not sink because the risk is contained. It's only for one compartment. And we analyze significant amount of attacks. Again, from Target to RSA to Stuxnet to Yahoo to many others. Whenever you segment your network correctly, you might get damage, but the damage will be very, very contained. Most of the hackers, when they get to the network, or most of the malware, when it gets to the network, does not know what it's going to find. It just continues to scroll around. Whenever you block it, you do the right thing. So the first principle about the enforcement point is to start segment your network. So let me talk a bit more about segmentation. Let's look at this environment. Let's say that I would say, look, I have this major headquarters, and I have those, and I have those branch offices here, and here, and then I have those clouds, right? And I have some mobile users. So right now I have those islands, and if I will protect each and every one of them, I will probably be much more secure than before. So segmentation is no doubt the next parameter, and I want to show you if we will correct and organize the business correctly and segment between each one of them, we're going to have a much, much better security. So we created a methodology of how to segment a network. It started by defining something called atomic segment. This is the very basic segments of the network. Segment is based on host or server that have the same classification and the same authorization. I'll give you an example. If you go to inside finance and think about collections inside finance. So collection has the same level of classification and authorization, and that's a segment. Once you have that, you start building bottom-up the organization from small atomic that you group them together and you group them together until you have a couple of islands, and then you connect them with the VPNs and you map the organization. So this is an example, data center on a corporate side, 2 branch offices and a mobile user. I want to show you something that I don't think you show. I have this amazing capability to show you that there is a bot over here. You see? Now, if I would just block these things, then the bot will stay over here. It will not start spreading around the network and steal your data or ruin something. So we need to do it all over the place. I will start doing those atomic segments. You see, I mapped the data center to have productions and sensitive information and labs or whatever. I can look at the LAN and say I want to separate between HR and finance. DMZ can be one or a couple of them. A few branch offices, I might say, look, here on the mobiles I have executive and the other people or whatever it is. So I have very small things then. Now I start grouping them together and said, actually I can look at the whole data center and the whole LAN and actually maybe all the corporate building to be one. And I stay with that amount of 4 big islands. Now I'm using a VPN and I just connect them. And suddenly I map the organization bottom up. On each and every segment like that, I'm going to put a gateway, and it's great things. The only problem is that I find myself with plenty of gateways, which is great to my business. But I don't want you to have so many gateways out there. So you can use virtualization. And if you use it correctly, you can actually provision more and more of those protections and have segmentation on the virtual world. By the way, it's relevant for the data center when you're using virtualization. And those next generation data center, it's relevant to your LAN using VLAN. So you have like one gateway with a lot of segmentation around it. And that's the way to look at it. So that's about the enforcement point. You can put it all over the place. segment your network. The second layer I want to talk about is the control layers. So control layers is where you generate the protections, and there are basically two kinds of controls. One control is the data and access control. This is where you define who can access where, either the data or the network. We're all using it. The basic principle behind it is very simple. I can say, as such, I can say Jim can access the server, but he cannot access Google Drive, and he can access the between the two servers, for example. This is a very basic policy. Who can access what? You know what's the other name for that? That's basically firewall, or next generation firewall. Next generation firewall, meaning I'm not talking on the port and IP, I'm talking about user and application. But this is basically access control. Access control is basically a firewall, and most of you guys are using firewalls. It's become a standard. It's important. It's really, really important. But the question is that enough? Probably not enough, because there's bad guys out there. So it's not only about me controlling who can access what, it's also about finding the bad guys and know how to solve that. And when I'm talking about bad guys, I want to talk about different kind of threats that we see. There's basically three kinds of them. One called known. So this is we know about, and we know how to protect. The easiest example will be viruses. So you can have antivirus, you have a signature, you know about it, you block it. I have a malicious website, I know about the URL, I block it. I've seen a bad document or document file, I have a hash of it, I know how to identify it, I just block it. The second environment is what we call known unknown. So we know about something, but we don't know exactly what it is, so we don't know exactly how to block it. But we know that there's vulnerabilities inside documents. We know. But we don't know the exact vulnerability. It's a zero-day vulnerability, so it's a zero-day by default. We don't know what it is. But there are technologies, mostly by behavior, that allow us to find those vulnerabilities and block it. So we're using mostly sandboxing and emulation in order to do that. So a document will come to the organization, we'll open it on a sandbox, we'll look how does it behave, and according to that, we'll decide if it go in or not. Checkpoint have a threat emulation solution for that, which is a great, very robust capability to do so. And the last thing is the unknown. So things that we don't know about, and we don't know how to protect, and we are not protecting, because we just don't know about them. The interesting part about the unknown, that some of it will actually move to that path. So at a certain point in time, there will be threats out there that we'll know about them. So we'll need to make sure that the infrastructure that we have today will be capable also for new technologies and new threats that are coming from the unknown. There's plenty of those technologies. I think you're going to hear a lot today about all the things here on anti-bot and IPS and threat emulations and all of those technologies Checkpoint have. As you can see, in order to protect against what we know or what we know that we don't know, it's always a multi-layer of protection. So a significant amount of more and more technology that you put in prevention. So what do we need after we understand that? We need a very basic policy. It's not like access control that's very complicated, you push it all the time. We need a straightforward policy that said, I just want to block the bad guy. Very, very straightforward. They make it very easy for me to win, as you can see. It's not that difficult. So we are adding to the control layers another component that's called threat prevention. We have all those multi-layer protections, all the IPS and anti-bot and threat emulation and your filtering and application control and so forth. We're taking all of those control, we push them to the same gateway. So if you already have those gateway, you don't need another devices, you don't need another management, you don't need to complex your network. You just use the same thing that you have today for access control and just push for them also threat prevention. So this is great. Now, the question is, how can I make sure that I have the best threat prevention? And really, the best threat prevention is based on something very, very important. It's based on intelligence. Because you don't, the policy is very simple, right? I want to block the bad guys. The question, who is the bad guy? It's quite difficult. And these bad guys changed all the time. If you're looking at bots' behavior, you'll see that they change their domain every 24 hours or even less than that, all the time. So you need to find where are they, what they do, how does they change. And you're going to hear more today about intelligence. So you need to collect all of those intelligence and translate them into protection. So what we do in Checkpoint, we do two things. One, we create our own intelligence. It's a massive, largest big data security that exists today in the world. We collect information from about 1 million gateways that we have out there. Not all of them share our information with us, but it's still significant. We have sensors. We have a group of 150 professionals that's what they do in life. So a lot of research. We also get things from the industry. We're getting from vendor, from CERT organization, only different research organization that gives us a lot of information from forums and feeds and many things else, and we translate it into protection. So that's how it looks like in a much better way. External and internal collection of information, create huge big data security, doing a lot of analytics on top of it, and at the end of the day, we generate indicators. Indicators are basically the protection that you're familiar with. It could be a list of URLs, or a signature list, it could be a hash files list, and so forth. So that's the information we generate together with the metadata that explain what it is, and we push it into protection. Again, the most important thing that you have this infrastructure is to block things when they happen, not just detect them, but really to block them. So we built that system. It's called Threat Cloud. It's a very robust one, working very, very good. But then we understand that actually intelligence collection is not one-time efforts. It's an ongoing effort that we need to do more with that. And exactly like physical intelligence, the key there is collaboration. The key is to work out with any resource that you can. So we said, let's open it. Let's just open our Threat Cloud to everyone who have this ability to get more information. And there are companies around the world that this is what they do. They collect intelligence. They analyze. They know how to trace the actors, the bad guys. And this is what they do for a living. Mostly they sell their intelligence mostly to financials and to governments. And we see more and more large organizations into that. Quite detailed information, very important information. There's one problem about that information. It's usually a report. It's usually something that you get to read, but it not necessarily protects you enough. It's important to understand what's going on, but we actually want to take this intelligence and translate it into protection. So we open our Threat Cloud. This is a list of partners that we sign with. The first one, I think John is here, the CEO of iSight Partners. He will going to talk more about intelligence. You can get through our system, actually buy that intelligence, and we will take those information to you, to our Threat Cloud, translate it into protection, and we'll push it to your environment. Get it in your logs and everything. So that's the idea. You can pick and choose. I want to have whatever, those 3 sources into my cloud, translate into protection, and push into your environment. So the combination of intelligence that translates into protections in real time is extremely, extremely important in order to be efficient in the cyberspace. Let me talk about the last layer, which is the management. This is our daily life. Most of you guys that manage security know that this is what you do on a daily basis. It's so important for us. And there's 3 important characteristics when you're talking about management. Modularity, I mentioned before. Modularity is a key in security. We created those models, for example, by having those segments. And now I can deal with each and every segment differently. And I need the management to support it. I need to do much more automation because the IT environment became so complex that I need to do something about it. And to try to automate as much as I can for different things, especially on this virtual environment where you can provision system on the fly. And the last thing, which is extremely, extremely important in security, is visibility. So modularity, the idea is that I want to support 2 things. I want to support segregation of duties. So if I'm managing access control and somebody else is managing threat prevention, I want to have the capability for both of them working on the same policy, on the same gateway. And that's what we're doing. So I can have here John working only on access control on this gateway, and Jim working with him here on the threat prevention on the same gateway. But more than that, we are introducing a new concept of management called layers. Layers of policy. So in the policy, you can have layers and then sub-layers and then sub-layers. For each and every layer like that, you can have administrators that manage the policy in parallel to other people working on a different part. So you can have endless amount of granularity in the management to support any kind of structure that you build your own network security, any kind of segmentation or any kinds of segregation of duties that you want. The second thing is automation, very basic things. I have a CRM system, somebody else coming to the organization, I just want to connect it automatically to the management. There might be here a cloud with different objects. I want the same object to be for my security and for my cloud. Or I just, for example, provision a new virtual machine that's happening all the time. I want automatically to create a virtual gateway that will protect him with all the relevant control through the manager and close the loop. And it all can be done automatically. So we open and we suggest the management will be totally open in a secure manner with API and any web services that you can get out of it and script your own stuff with any tools that you want. And the last thing is visibility. You really, in order to really understand what's going on, you really need to collect a lot of information from a lot of sources because attack is not like one thing that happen according to your protection. It's happening by totally different ways. And I've seen attack that you start one way when you go in, but when you go out, it's basically a DLP could have solved the attack. So you can find it could be firewall, it could be IPS, it could be at the endpoint, it could be on the cloud, and all part of the same attack. So you really need to correlate all of it. And the idea that you can actually collect information from endpoint, from gateway, from cloud, from mobile, whatever it is, get one console picture that actually correlates it all with a full drill down. Understand that you might have a problem, generate a new protection, push it to the threat cloud, and then push it to your own gateway. That's the key about visibility. So if you create that cycle going on, you really have a simple way to manage your SOC environment and to continue and protect your organization. So just to summarize on my architecture, at the end of the day, that's the picture I want you to remember. 3-layer architecture, very flexible, very robust enforcement point with segmentation, adding threat prevention to the controls. It's not enough to have only firewall and know how to manage it all together. To summarize, this is my daughter. She asked me to say that I have a lot of work to do on that aspect, and I fully agree with her. That's not my profession. But I really want to take that. A modular environment that's very dynamic, the combination of intelligent that translates into real-time protections. This is an architecture that will serve us today, but will serve us moving forward. The team is here, and it's relevant, the team here and also the headquarters will be happy to work with each one of you to analyze your environment, to understand how do you structure it today, and to go with you and design your network moving forward. What's the thing that you want to change? How do you want to consolidate your network? And how you're going to be very much more secure than what you have today. It will not be like a product session, but an architecture session. We have a group of architects at Check Point that really helps making it happen, and I really want to take this advantage and invite you guys to use it. It's more important than just another product that you have out there. I see you as partners. We're working here for many, many years together. It will be my honor to invest the resource of Check Point in order to make sure that your environment is much more secure than that. So thank you very much. I hope it will be a great day and a very secure one. Thank you.